Today we're going to take a look at graphing rationals, and this is our first day of graphing rationals. Oh dear. Okay, see if I can get this written. All right, so the first thing, let's do a little review. So if I had the equation f of x equals x minus 2 squared plus 3, what would you say this was? You would say this is a parabola that moved to the right 2 and up 3. What about if I had one that said the negative absolute value of x? You would say that this one is a reflection. And it's a reflection over the x-axis because it's the opposite y value. Here, let me flip it down. So we have done some stuff with translations. The first thing now that I want us to take a look at is let's use our graph from yesterday. Let me get some graph paper here. So let's graph what our equation we started working with yesterday, 1 over x. So f of x equals 1 over x. And so what we're going to do is put some anchor points here. So 1, 1, negative 1, 1. And then we said it made this lovely little swoop. So a couple things about this. Is there a y-intercept? No, there's not. Where is there a horizontal asymptote at? Well, it never crosses the x-axis, so it's at y equals 0. And where is our vertical one at? Well, that's at x equals 0. So it has some asymptotes there. So next thing we're going to do is I want us to see, can we come up with some equations, some transformations of 1 over x? So let's take a look at this one. What would you describe that this one has? And you'll notice these dashed lines are asymptotes there. So what happened to this one? Well, you might be looking at it and say, well, Miss Husing, that's easy. It moved up 5. So how would we write an equation that says it moved up 5? We have our 1 over x. Well, it moved up 5. Okay, so plus 5. Because you'll notice instead of 1, 1, this one it moved up to 6, and that one it moved up from negative 1 up to. So let's take a look at this next equation. Well, what happened here? Well, it was originally here. So it was a reflection. And it could say a reflection over x or the y. So we'd have the opposite of 1 over x. So let's see, what is our next one here? Let's see what we can come up with. The function has a vertical asymptote at x equals negative 3 and a horizontal at y equals 0. So we're asked to find this equation here. All right, so let's see, what do we know? There's in this, whoops, let's see if we can get, I don't have the graph paper up. I don't know why that disappeared. So x at negative 3, so a vertical, and again, we'll dash those in. And at y equals 0, so right here. And it has a point of negative 2, 1, and negative 4, negative 1. And the y-intercept is 0 and 1/3. So we know that this is a shift. And it shifted to the left 3. So how do we say to the left 3? Well, that goes next to our x, so it'd be 1 over x plus 3. And I can double check when x is 0, 1 over 0 plus 3 is 1/3. So if I was to plug in the coordinate 0, we'd have 1 over 0 plus 3, which is our y-intercept of 1/3. So let's take a look at this next one here. So what happened to this one? Well, Miss Husing, it moved to the right 2. Well, how do we say to the right 2? Well, that would be 1 over x minus 2, since it shifted to that right. So the next thing we're going to look at, what is our next one here? Oh, so it's another one with some equations. All right. So let's see what we can do here. So our asymptotes are still those axes. And then let's see, what point does it have? 1, 2, negative 1, negative 2, 2, 1, negative 2, negative 1, 1/2 goes up to 4, negative 1/2 goes down to negative 4. So I'm going to think about those anchor points, 1, 1, and negative 1, negative 1. Well, what happened to 1, 1? Well, it went to 1, 2. And what happened to negative 1, negative 1? Well, it went to 1, negative 2. So our y value doubles. So we want to double our whole thing. So if you remember, that's 2 times our entire equation. So it's not just next to the x. And if we multiply that in, that would just be 2 over x. So let's take a look at this next one. What happened here? Well, it moved to the left 1 and down 4. And it looks like those points, so those anchor points are still right there, like over 1 up, 1 backwards, down. So those haven't moved at all. So they've all moved to the left 1 and down 4. So what would our equation here be? To the left 1, we'd have x plus 1. And then we have down 4 minus 4. So how about this next one here? All right, well, let's see. This moved to the left 1. Or not to the left 1. 1, 2, 3, 4, 5. To the right 5. And up 2. And it looks like something happened to our anchor point. So 1, 1. Let's see. Well, now is, let's see, that's 6, negative 3. And let's see, negative 1, negative 1 is now 4, 1, 2, 3, 4, 5. Is that 5? There. 4, 1, 2, 3, 4, 5. So something's happened here. Well, they flipped. Well, it moved over 5. So we can see that here, that this has moved over 5. But what happens here? We notice that that flipped 1 to negative 3. Huh. Well, let's see. So we know that it moved right 5 and up 2. But how do we get that anchor? We have to figure out, well, what happens now to that anchor point? Well, let's take our first anchor point, 1, 1. It moved to the right 5 and up 2. So that becomes 6, 3. Well, then it flipped and we have that negative. All right, so that works. And how about negative 1, negative 1? It moved to the right 5, so that would be 4. Up 2, so that's 1. And it went to 4, 5. So we have to figure out, this is some sort of vertical stretch. And I'll tell you what, for right now, I'll be all right if we don't identify the vertical stretch, as long as we recognize that there is some sort of vertical stretch. And again, we know there has to be some sort of vertical stretch, because if not, our anchor points would be right there. But something changed within our anchor points. All right, so the next one, a vertical asymptote at negative 6. 1, 2, 3, 4, 5, 6. And y equals negative 3. Let's see, a point is at negative 5, negative 4. And another point is at negative 7, negative 2. So we can see here this one does not have a vertical stretch, because that point, it's like over 1 up, 1 from, I like to say, kind of our new origin. So this would be 1 over x plus 6 and then minus 3. All right. So the last thing that we are going to do is let's take a look at how we can graph some of these. So if we go the other way, and I was to give you 1 minus 1 over x plus 3, how would we graph this? Well, first of all, we could identify our asymptotes. So x plus 3, so x minus 3. So there's a vertical asymptote at x equals negative 3. And there's that 1, it moved up 1, so there's a horizontal asymptote at y equals 1. And then what does that negative do? Well, we said that negative is just a flip. So here were those anchor points, and then they have to flip, and it's opposite the entire thing. So it would flip, and then we would have our graph right here. All right, very last one that we're going to take a look at is y equals negative 2 plus 3 over x minus 4. So again, we can take a look at where our asymptote's at. So this is x minus 4, so there's one at x equals 4. That's our vertical. Sorry, this is getting a little bit messy here. And then where's our horizontal? Is at y equals negative 2. And then let's see. The other thing I want to worry, we know that it is a vertical stretch of times 3. But again, I'm not too worried about that. The other point that I want you to have is your y-intercept. So when x equals 0, so negative 2 plus 3 over 0 minus 4, well, that'd be negative 2.75. So I could graph 0, 1, 2.75. And so there's no reflection, so we know this must be a, whoa, that didn't swoop very well. So we have a swoop going up here. And then we have a swoop. We must hit that and then go down there. That's a terrible messy graph there. I apologize about that. So, but we have our swoops.